Alright, question 10 says, state Newton's first law. That's pretty basic. An object at rest will remain at rest, and an object in motion will remain in motion in a straight line unless acted on by an external unbalanced force. Okay, and we call all of that collectively inertia. Okay, easy way to remember it. Newton's first law, the one kind of looks like an I, so first law I for inertia. Alright, questions 11 through 13 kind of test that. The first one asks about a small weight on top of a playing card on a glass. Something like this. You saw this demonstrated in class. So this is an object at rest. It wants to remain at rest. So if you quickly flick the card away, because this mass wants to remain at rest, it will drop into the glass since there is no upward force acting on it anymore. Okay, for question 12 we have a ball in a trolley. So I'm going to look from the top down. So here's my trolley and here's my ball. Question A says that it's accelerating suddenly from stopped. So if I suddenly move the trolley, well, the ball is at rest and it wants to stay at rest. So when the trolley starts to move, the ball's going to end up at the back of the trolley. Okay, it's not moving backwards, it just wants to stay where it is. It wants to stay at rest. If the trolley is already moving, okay, and here's my ball, and I suddenly stop the trolley, let's say by running it into something, don't try this at home, the ball wants to keep moving, okay, so it's going to end up at the front of the trolley because an object in motion wants to stay in motion. For question C, if the trolley suddenly took a left turn, so it's moving forward, and then all of a sudden it turns left, okay, the trolley is going to end up like this. Okay, so the ball's there, the ball wants to keep moving forward. Okay, so when the trolley goes to the left, then the ball is going to end up being on the right side of the trolley because the ball wants to keep moving forward, but the trolley is moving into its path, and so it will end up on the right hand side of the trolley. Question 13 is very similar. It says that if you're in a car and the car suddenly takes a right hand turn, it feels like you, if you're the passenger, are being pushed to the left. Well, you're not actually going to the left. You're wanting to go straight forward, but the car is turning into your path, so from your point of view, you're ending up on the left-hand side of the car. Alright, question 14 asks us to draw free body diagrams for this example roller coaster cart. The four forces that you always want to put in are gravity, you want to put in the force of the surface, which you might either refer to as the force of the rail or the normal force, which is its more proper name. Okay, so one of those two, not both of them. You just go with whichever one I've shown you for the particular class that you're in. You want to put down any applied force, so that's if it's accelerating or decelerating, has an applied force. And you also want to put in the force of friction, which is present when it's moving at any speed. Okay, so gravity goes in all of them, like so. The normal force, or if you like the force of the rail, only goes in when the rail has to push up on the cart. Okay, so that doesn't apply in the top one, but it does apply in the other ones. And if it forms part of a curve, it always points towards the center of the circle that it makes. Okay, so the normal forces, or the forces of the rail, are at right angles to the rail itself. And lastly, if the car's going from left to right, if this is the direction of travel, then you want to put the frictional force in, and it's opposing movement, so it's always in line with the rail itself. Okay, so if the rail's on an angle, frictional force is on an angle as well. Now in this particular example, there is no applied force for this particular ride, but if you were looking at something like the Tower of Terror, or some ride where there's some sort of push somewhere, then you would write in the applied force, and you do that in the direction of the push. Okay, so if it's the applied force is in this direction, that means that the cart is being pushed in that direction, it's being accelerated in some way. Or if the cart is braking, that means that it would have been going the other way. If it's going this way and the cart's braking, then you say it's braking, the brakes are pushing on it that way to slow it down. Okay, so whether it's accelerating or decelerating, you write in the applied force there. Question 15 says state Newton's third law. It looks like this. For every action, there is an equal opposing reaction. So a very familiar example, I push on the wall pushes back on me with equal force. So I have an action, which is me pushing on the wall, that's the action, and the reaction is that the wall pushes back on me, and the forces there are equal. Okay, an equal opposing, so it's in the opposite direction, reaction. For every action, there is an equal opposing reaction. I can also use this example to answer question 16. If I'm in this situation and I'm on roller skates, in other words, there's very little friction with the floor, when I push on the wall, I'm going to move, because if the wall is pushing on me, I move, right? Especially if I'm wearing skates. If I was wearing something that didn't have much friction with the ground, like really slippery shoes, then it would move as well. Why? Because the wall is pushing on me as well. Alright, in question 17, we have a cricket bowler running up and bowling a ball towards the batter. The question says, what force acts on the bowler? So we can draw a diagram of that. Alright, so the bowler is in motion, right? The bowler is moving. He, let's assume it's a he just for this example, he pushes on the ball and the ball pushes back on him with an equal force. Okay? So the effect that has overall is it's going to slow his arm down, right? If he's moving and his arm's moving and the ball pushes on him, okay, that's this force here, then the force of the ball on the bowler is going to slow down the bowler's arm and probably slow the bowler down as well. The heavier the object that the person is throwing or pitching or whatever, the more forceful the pushback is going to be, and therefore the more it's going to slow the person down. If you're talking about a shot put or a javelin or a medicine ball or something heavy, they push harder on the person, and therefore it's going to slow them down more. Okay? If it's a light object, it won't have as much of an effect, but its overall effect is to slow the person down, or to slow that part of the person's body down. Okay, question 18 says state Newton's second law. If you don't know that by now, you have in fact been asleep. All right, F equals ma. And so therefore I can use that to answer question 19, which is that if I apply the same force to a tennis ball and to a bowling ball, the same size force, okay, the effect is that the bowling ball will accelerate more slowly. Okay, it's got a bigger mass, and therefore the acceleration has got to be lower for the same force. All right. If I have a small ball, then it's going to accelerate faster because it's got less mass to it. Okay, pretty straightforward. All of that is quite intuitive, right? Your instinct tells you what's going to happen there, and your instinct is correct. All right. So for questions 20 through to 24, they're basically just calculations using F equals ma. Again, I'm not going to talk you through every single one. I'll just display the answers on the screen, and you can check the working for each one to make sure you have the answers correct. Okay, so there's 20, 21 and 22. Remember, you need to make sure that this is in kilograms. Okay, that's the only really tricky thing there. And lastly, with questions 23 and 24, the question doesn't give you the acceleration, you have to work it out. For example, 23 says it goes from 0 to 8 in 2 seconds. Okay, so you have to work out the acceleration, and then you sub the acceleration into F equals ma. Okay, same with the question 24, you sub the acceleration in. So expect to see something on the exam that's something like that. All right. If you need to email me to ask a question, don't wait till the last minute, but my email address is bcoss9@eq.edu.au. Alright, or come and see me in staff room 1.